Okay, so now we're going to look at cuboids. So the first thing we're going to do is, this is a net of a cuboid. So this is a shape that when we cut it out, we're going to be able to make a cuboid. And a cuboid is pretty much just a box, a rectangular box. So you have your printable there. So if you have this in front of you, get cutting it now. And if you don't, you can just watch me. Okay, so I'm going to cut this net out. Okay. And hopefully, if we've drawn the net correctly, when we fold all of the pieces of paper together, it should fold nicely into a box. So if you could imagine going around the house and maybe picking up a cereal box or a box that aftershave or perfume comes in, something like that. If you pick it up and you just take it apart and flatten it out, well, then it will flatten out into some sort of net shape, a shape that when you fold it back together, it will make the box. Okay, so nearly there. Okay, I already have some little pieces of sellotape ready for putting this little box back together. Okay, so now my net is all cut out, my shape is all cut out, and now I'm going to fold it to try and make the box. Okay, so my box here in my picture is blue on the front, so my box is a bit like this, isn't it, where it's blue in the front, grey on the sides, and this red bit on the top. So I'm going to start folding my box together and see if I can make that. The trickiest thing about nets is making sure that when you fold it all back up together, that all the little sides match. That's the tricky part, that they all line up. You'll see what I mean now in a minute. So I'm just making my folds. So when I was drawing this, I made the lines sort of, the fold lines a little bit thicker so that you could see them, okay? Okay. And hopefully it should all bend into a little box. Okay? You see that? Now what I was saying about, these are the hard bits, look. Making sure that these bits line up. So you can see that this on the grey, this is 4 units. And the red is 4 units. So that's good because those two are going to match up okay. And make my little box. Same here, my 4 units here on my grey and my 4 units on my red are going to match up. So that's perfect. What happens some people is when they go to make their box, one bit's longer than the bit they're trying to match up with, and then the box won't come together. Okay, so what we've done here is we've actually taken it from a 2-dimensional flat shape, and now we're bringing it into a 3-dimensional volume. Okay, so a cuboid is actually a volume. Okay, insofar as it takes up space. 2D is more like watching television. Okay, it's a flat screen, or watching your computer or your phone. They're flat screens, and we took this flat net and we are now making it into a little box. Look, you see the inside? There's my little box. Okay, so you and I would call this box. But when you're in maths class and you're all very fancy indeed, you would call it a cuboid. Okay, just fancy for a rectangular box. Now, so there's my cuboid. You can see how many faces does it have? 1, 2, 3, 4, 5, and 6. So there's my wee box. Now, if we look then, the most important thing here to remember is how the lengths need to match up. So do you remember I said this red and this grey, it was very important to get those to match up. Okay. Now, and this is called then a net. Thinking about the words, it's a net of a cuboid. Okay, and if I was to put some labels on it, so this blue part would be the front, and this would be the back, this would be the top, and this would be the bottom, and then this would be one of the sides, and this would be another side. Okay. Now, in questions, in your junior cert or your leaving cert, you can be asked to draw an accurate net of a cuboid from a given picture. So what they might do is actually give you the picture of the cuboid and ask you in your mind's eye to imagine taking all of the tape off and flattening it out into what it should look like. Okay, that can be pretty difficult. All right. Now, some things to bear in mind is if you're asked to flatten this out in your mind's eye, okay, is that in your maths copy, the squares are 0.5 of a centimetre in width and height. So the wee squares that you work on in your maths copy and the squares that are in the leaving cert and junior cert on the page are 0.5 centimetre in width and height. Okay, so if you're looking to make 1 centimetre, which is what I did here, these are all 1 centimetre in width and height, well then you would use 2 squares in your copy. Okay, and if you look at the diagram here on the page, or the diagram here on your screen, this is just a little 3D image of what we're just after drawing, and you can see that every square has a height of 2 boxes. Okay, so the grey grid behind is like your copy, and then the diagram on top is measured in centimeters. So each of these little squares, you see this one here, you can see it's 2 boxes high. Okay, you would never be asked to draw this, by the way, I'm just letting you know. Okay, 2 boxes high would be 1 centimeter. Now another note is maybe use a scale if the cuboid dimensions are too big. So what if I asked you to draw the net of a garden shed? Okay, so that's way too big. So in that case, you might let 1 centimeter on your page be the same as 1 meter in reality. Okay, so you can choose if you need to do some sort of scale. So some examples here are maybe one of your boxes, your 0.5 centimeter could equal 5 centimeters, or maybe 1 centimeter could be 10 centimeters, maybe if you're drawing like a television screen, or 1 centimeter could be 1 meter if you're trying to draw like a shed or something. Okay. Now, this is a very important thing to note. There are many different ways to draw the net of a cuboid. Okay, so your neighbor might draw a different picture. So you could be doing this in class and look to the other side and your neighbor's net looks different. And that's because there's lots of different ways of opening up a cuboid into a net. So here's another example where instead of the flap coming off the blue part, like I did, I made my flap coming off the blue part. Okay, so I'll show you what I mean. I'll open this back up. Let's just cut it there. Okay. Okay, so my flap here is coming off the blue part, like this. Okay, this person, whoever's drawn this net, they've visualized it different. They've, in their mind's eye, said, no, the flap doesn't come off the blue part. Okay, so in their head, they're saying, no, the flap comes off the grey part, and they're going to close theirs like that. Okay, so let's see. That would be perfectly fine, wouldn't it? I mean, if I had mine closing like this, where it flaps over like this instead of hinging on the blue side, that's still going to make a perfectly good cuboid. Okay, so what you'll find is there's numerous ways to draw a net. Okay, so don't be disheartened if your version is different to a version you see in a book, an exam paper marking scheme, or your neighbor. But here's the clincher, isn't it? No matter what you do, it'll all be good if you make sure that your sides match up for when you bend it over. So this red part would have to make sure to match up with this blue. Look, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And once you do that, no matter what you draw, you'll be right. Okay, now sometimes we can actually be asked to find the area of a net. Now, the formula for area of a rectangle is length by width. Okay, so on my red part, I have 6 centimeters by 4 centimeters. So 6 by 4 is 24. And I'm so lucky here because on a cuboid, the area of the red is the exact same as the area of the red on the other side, 6 by 4. So that's both of those answers will be the same, area of 24. Let's look at the front. I have 6 centimeters by 8 centimeters, which is 48. And again, that area is the same as this area. And then lastly, I have my grey part, which is 4 units by 8 units, which is 32. And again, that grey part's the same as that grey part. So if I want the area of my whole net, just add all of those answers together and I have 208 centimeters squared. Now, I asked you what's the area of the net. Another way to describe this is, well, what's the surface area of the cuboid? That would be more usual on how you would be asked in an exam question. What's the surface area of this cuboid? So that's a new word for you, surface area, which is the same thing. It's the area of the net when you flatten it out into a two-dimensional plane. Okay? So same answer, surface area of this is still 208 centimeters. So let's look at another question. What is the total surface area of this carton of tomato passata? Okay, so here is a carton of tomato passata. And the dimensions are, I have these measured out already for us. So measuring from your 0, I have 14 centimeters here. The width is 7.5 and the depth here is 4.5. Okay, and this is clearly a cuboid. So here I have a net drawn out for this. So I have my front and my back, 2 sides and the top and the bottom. And again, you can see that I have the top and the bottom on my one hinging off the front part, okay, but perfectly okay if you want to hinge off the side. Okay, so a question in your junior or leaving cert or cycle, whatever it is at the time, could be, what is the surface area of this cuboid? Okay, now note, remember, the front and the back are the same. The top and the bottom are the same and the 2 sides are the same because this is going to save us time. So really all we need to do is get the area of the front and multiply it by 2. Okay, and you can see I have that here. So 2 fronts would be 14 by 7.5, multiply that by 2 for the front and the back. So that's 210. 2 tops, in other words, the top is the same as the bottom. So 2 tops. So this is 4.5 by 7.5 multiplied by 2 is then 67.5. And then finally the 2 sides. So a side is 14 by 4.5 and multiply that by 2 to get the 2 sides. So that's 126. Then it's always the total surface area. So add up all of your answers there and we 403.5 centimeters squared. Okay, so what would this look like in an exam question? Well, here's one from the Junior Cert Ordinary Level 2014. Okay, paper 2, question 9. A rectangular tank has a length of 10 meters. So we're talking meters now. So much bigger than this. It's a rectangular tank, maybe like an oil tank or something. It has a length of 10 meters, a width of 3 meters, and a height of 4 meters. A diagram of the net of this tank is shown below. So number 1, write down the values of A, B, and C, and then find the total surface area of the tank. Okay, so you can pause here if you want to take a minute to try and do out the answers of that. Okay, so the answers would be, the A part is the full length, so that's 10 meters. The B part is the longer of the 4 and the 3, so it's the 4, and the C is the smaller one, the 3. Okay, so find the total surface area of the tank in meters squared. So let's do 2 fronts, which would be 2 by 10 by 4, which is 80. 2 tops, which would be 2 multiplied by 10 by 30. Sorry, 10 by 3 is 60. And 2 sides, 2 multiplied by 3 multiplied by 4 is 24. Add them up and we get 164 centimeters squared. Oh, centimeters squared, look what I did. It's meters squared, isn't it? So you can change that. Okay, and I was just about to say, make sure now you do your units correctly, but obviously that's meant to be meters. Okay, so the next one then, here's another Junior Cert one from 2012. Kieran is wrapping a present in a rectangular box. Okay, so we've all done this for Christmas. How many faces has the rectangular box? Draw a net of the rectangular box. Now, see here, to a suitable scale. So 40 centimeters, well, that's very wide, isn't it? Like there's only 15 centimeters in your ruler. So that's nearly 3 times the length of your ruler. So imagine this is like a massive present. So, you know, you're going to have to scale it back down in order to draw the net of this. Okay, and then indicate in your diagram one pair of faces that are equal in area, and then find the surface area of the box. Okay, again, take a minute. Why don't you just do this into your copy and see if you can do it, okay? Because these are going to take practice. You're really developing your mind's eye, your spatial awareness. They seem easy, but actually they take a little bit of time to get used to. So why don't you try it and come back to me for the answer. Okay, so the answer then, how many faces has the box? 6. Now draw a net of the box. So remember I said that maybe you'll need a scale for this. So remember we talked about this, that one of these little boxes is 1/2 centimeter in height. So 2 of them would be 1 centimeter in height. And then I thought we could let 1 centimeter then be 10 centimeters in our scale. Okay, so when we're trying to do 40 centimeters, we could draw just 4 centimeters instead of 40. And to draw 4 centimeters, that would be 8 boxes on your graph paper, because each box is half, so 2 boxes is 1 centimeter. Okay, it's okay if you used a different scale, that's no problem. They just said a suitable scale. It's not one scale fits all, that's just the one I used. Okay, now so first of all then, here's the front and the back. So the front here is 40 centimeters wide and 30 high. So here I've got 4 centimeters, in other words 8 boxes, and 30 high, 3 centimeters, or in other words 6 boxes. So that's my front. Okay, beside my 2 fronts are going to be my top and my bottom. Okay, so my top then, this part here, is 40 wide and 10 back. So that's going to be 4 centimeters and 1 centimeter, which is just going to be 8 boxes and 2 boxes. So there's my 8 by 2, which represents 4 by 1 centimeters, which represents 40 by 10, really using my scale. There's my top, and then there's my bottom. And here's the back that will then fold back around to match the front. And then here I've done my sides hinging on the front. Again, no problem if you put them hinging on the side. So this one here that's shaded in grey, it's 30 centimeters tall and it's only 10 centimeters wide. I know that because that's the same as that is the same as that. So it's 10 centimeters wide. So 30 by 10. So 2 boxes for my 10, which is going to be 1 centimeter, and 6 boxes for my 3 centimeters, which is 30 centimeters. Okay? Now, so you can tell me, is that a hard question or an easy question? I think that's quite hard. And I think that'll take a little bit of getting used to. And if you find that it's taken a while to develop your mind's eye, keep drawing them out and cutting them out. Okay, once you do the net, cut it out and see if it works, because it's only then you're going to see where you're going wrong. Okay, this is a very hands-on kind of idea. Okay, so that's why I've lots of hands-on stuff here, so that you realize it is going to take a little while to develop your mind's eye. Some people, they get it straight away, and maybe they're just, they'll always be good at parking their car. Okay, but not everybody's going to be like that. Okay, and then the second part of this question, indicate on your diagram one pair of faces that are equal in area. So any of the ones that are equal in colour are going to be equal in area, the front and the back, side and side, the top and the bottom. And then find the surface area of the box. So 2 fronts are going to be, a front is 40 by 30 multiplied by 2, so that's 2,400. 2 tops, my tops actually, oh yeah, in this one the tops are the blue ones, aren't they, just the way it's sitting. So my 2 tops, then my blue, is 10 by 40, so 10 by 40 multiplied by 2. And be careful here, when you're doing the surface area, revert back to the original measurements, not the little scaled down ones that you used, okay? And then my 2 sides, green and green, are 10 by 30, okay? So 10 by 30, not 1 by 3, and not 2 boxes by 6 boxes. Revert back to the original dimensions of the box, 10 by 30. And I've 2 of those, so that's 600. Add those all up together and you've your total surface area is 3,800 centimeters squared. Okay, so really, look, you're just going to have to try a bit of practice on these. Go to your book, get out some and just practice them. Go to your exam papers, practice them, cut them out until you get used to it. Okay.